Welcome all. We continue with our biostatistics module, and today's topic for the discussion is levels of measurement. Okay, so the level of measurement describes how the data is classified, how the variables are measured, and which statistical test can be applied. So in the last session, what we have seen the data as such. We have talked about the variables also. Now we need, if at all there is a tremendous data, we need to classify that particular data. If there are many variables, we'll have to measure each variable. Okay, so what exactly we are going to do for measurement, how we are going to classify, that we are going to discuss today. Okay, and ultimately once you collect the data, you have to apply some statistical test also, and that will depend upon what type of data you have, what type of variable you are dealing with. Okay, so there are basically four levels of measurement. So one is a nominal, second is a ordinal. Okay, so here you, for understanding point of view, you put these two together, nominal and ordinal. Okay, so remember no, nominal and ordinal, and next you put learn together, that is interval and ratio, IR. Okay, so it is NOIR, out of which you study NO together and IR together, then you will understand it in a better this is just for the understanding point of view. Okay, so now last session we have seen the data as such, and we have seen the variables. Now we are going to measure these variables. So for measurement we need to have certain scale. Okay, now depending upon the scale of measurement, this particular thing, we have different levels. Okay, that is nominal, ordinal, interval, and ratio. Now let's see about the nominal. Nominal variable we have seen, these are just the categories itself only. Okay, so is there any intrinsic order? There is no intrinsic order. There is no equal difference between the two, and there is no true zero. In the nominal, it's just the categories like color of the eyes. Okay, the religion. Okay, sex. These are just the nominal data. There is no order, there is no equal difference, there is no true zero. Now come to the ordinal. Okay, where there is a intrinsic ranking. Okay, what we have seen as pain severity, socioeconomic class, etc. So is there an order? Yes, there is an order, but there is no equal difference between moderate pain is not 2 times or 3 times of the mild pain, but moderate pain is more than the mild pain. Okay, so there is an intrinsic ranking, but there is no equal difference, and there is no true zero. Okay, while now it comes to the interval and the ratio scale. So this is the two you study together. So in nominal scale there is nothing, there is no order, there is no equal difference, there is no true zero. While ordinal will have order. Okay, but equal difference is not there, and true zero is not there. Now next two are the interval and the ratio. And remember, the ratio is the highest scale. Highest scale means it will have the order, it will have the equal difference, it will have the true zero also. Okay. Now, in what happens in interval scale? So in interval, there is a order. Okay, like ordinal. So there are categories. There is equal difference. So one category and another category, there is a difference which is equal, but there is no true zero. Here the temperature is the example. Like your 40 degrees centigrade is not the 2 times of the 20 degrees centigrade. Okay, 80 degrees centigrade is not the 2 times of the 40 degrees centigrade. Okay, but there is a difference because you are measuring the temperature on a particular scale. So 20 and then the 40 with a certain interval, same interval will come 20, then it will come 80 or 60 or 80 sort of thing. Okay, so the interval is going to be same. Okay, but there is no ratio as such. The ratios are are not meaningful here. In ratio scale, there in ratio scale there is an order which is there. There is equal difference between the categories, and there is a true zero also. While in interval scale there is no true zero, that you please remember. Okay, in interval scale there is no true zero. For example, for interval scale is the temperature. Okay, and most of the other continuous variable what routinely we measure, they are the ratio, and ratio is the highest scale. Okay, now let us see one by one. So nominal and ordinal we'll see first. Okay, in nominal scale data is divided into categories only. There is no intrinsic order or the ranking. So key features are there are only categories. There is no ranking. Then weakest, this is the weakest scale, and numbers used only as labels. Okay. So examples are the sex, male, female, blood group A, B, AB, O, eye color, such as blue, brown, religion, Hindu, Muslim, etc. You may code this particular, like male is given code 1, female is given code 2, but these are only labels. The mathematical operations are meaningless here. 1 or 2, you cannot do any mathematical operations with this. Okay. And what type of statistical methods? So suppose your data is of this particular type. So your data is a nominal data, and it is measured on a nominal scale only. Okay. So what type of statistical methods you are going to use? You will only measure the frequency. You will measure the percentage. You will calculate the mode for this, and the test you are going to use a chi-square test for the proportion. Okay. So you will use the chi-square test. So statistical method here, one is how you are going to describe the data. You will describe the data in terms of frequencies and the percentages, and you will summarize with mode, and chi-square test you are going to use for the statistical significance. Okay. So examples are the blood group, eye color, gender. These are the nominal scale. Okay. So A, B, A, B, O, that is a nominal scale variable. Okay. Then second scale is ordinal. Okay. What happens in ordinal scale? There are categories which can be arranged in order or rank. Okay. Exact difference between the categories is not equal. So there are categories, but the difference between the two categories is not equal. Okay. So key feature is that the category has got order, then unequal intervals are there. Ranking is possible here. Okay. So for example, pain severity, mild, moderate, severe. Okay. So mild is definitely less than the moderate, but how much less, that cannot be defined. Same thing is about cancer stage. Stage 1, 2, 3, 4. Okay. Socioeconomic class like low, middle, high. Then educational status, primary, secondary, graduate, etc. So this scale is the ordinal scale. Okay. Here, the exact difference between the categories is not equal. Okay. So difference between the categories is not measurable here. This point is differentiating it from other scores. Okay, other scales. So difference between mild and moderate pain is not same as the difference between the moderate and severe pain. Okay, so difference between these two is not same as difference between these two. Okay. So what kind of statistical methods you are going to use? So you will describe this in terms of median, then percentiles you can use, and the test statistical test which you will apply are the non-parametric type of test here. Okay, so if you are having a data which is ordinal in nature, then you will use median and the percentiles for description, and non-parametric test for the statistical significance. Okay. Examples are the cancer staging is an ordinal type of pain score, socioeconomic status. Okay. Same example, mild is less than the no pain is less than mild pain is less than moderate pain is less than severe pain. So there is an order over here, but the intervals are unequal. Okay. Now next scale is the interval scale. Okay. Now interval and ratio, you understand it in a better way. Okay. The first what we have seen is the nominal scale, where there was nothing. In ordinal scale, there are orders, but rest of there is no true zero. Okay, the difference is not equal. While in interval scale, there is a numerical scale with equal intervals. But only thing is that here there is no true zero. Okay, so this interval scale and the ratio scale, this zero difference is there. That means here there is no true zero, while ratio scale has got a true zero. Okay, so interval scale, it is again ordered. It has got equal intervals. So categories are there. The difference between the categories is equal. Okay, while in ordinal scale, it was not like that. Okay, in interval scale, the difference between the categories is equal, but zero does not mean absence. Okay, so the best example is the temperature. Okay, so the temperature which is measured in centigrade. Okay, so this temperature which is measured in centigrade becomes the example, not temperature which is measured in Kelvin. Okay, So temperature which is measured in centigrade. So 0 degree centigrade does not mean absence of temperature. Okay. So 20 degree centigrade is warmer than 10 degree centigrade. Okay. But here the ratios are meaningless. That means 40 degree is not twice as hot as 20 degree centigrade. Okay. But there is a difference. Okay. And the difference is equal. So when you put together 0, 10, 20, so the difference is uh, there. Okay. But it does not, you cannot apply the ratio. You cannot say that this is 2 times the 40 is 2 times as hot as 20. Okay. Here, what kind of statistical test you are going to use? You will describe this with mean, standard deviation, and you will use parametric test. Okay. Here, the parametric tests are used, while previous in ordinal, what kind of test we have used? We have used the non-parametric test. Okay. Here, the non-parametric, it was the median, percentile is used for the describing, and non-parametric test was used. While here in interval scale, what we are going to use is the mean, and standard deviation is used for the description, and parametric test can be used. Okay. So this is a little higher category, a higher type of scale as compared to the nominal and ordinal. Okay. But the highest is the ratio one, which we will see. So Celsius temperature is the interval scale example. Okay. And IQ score is also an example of interval scale. Okay. So here interval scale, look at this figure. You have got 0 degree, 10 degree, 20 degree, 30 degree. Okay. So there are equal intervals. Okay. But there is no true zero. Okay. 0 degree centigrade does not mean the absence of temperature. Okay. 0 degree has got some temperature, which is, we are labeling it as a 0. Okay. So there is no true zero. So this is not a true zero. Now coming to the ratio scale. Okay, it is the highest level of measurement, similar to interval scale, but it has got a true zero. So the difference between the interval scale and the ratio scale is of true zero. Okay, but this because ratio scale has got a true zero. Okay, the key features are there are order in this particular data. Then it has got equal intervals, it has got a true zero present, and the ratios are meaningful. So we'll see with the examples. Okay, so for example, weight, 0 kg is the absence of weight. Okay, height, there is a true zero. Pulse rate, there is a true zero. Age, there is a true zero. Okay, it begins at 0. Okay. So from examination point of view, remember that ratios are meaningful. Here in ratio scale, the ratios are meaningful. Okay, you can say that 90 kg is 3 times heavier than the 30 kg. Okay, so here the ratios are the meaningful. While in interval scale, this was not meaningful. Okay, so statistical methods are all mathematical and statistical operations are possible. Okay. So weight is a ratio scale, pulse rate, age, these are the examples of the ratio scale. Okay. So 0 kg, 20 kg, 40 kg, 60 kg. Okay, here there is a true zero and the ratios are meaningful. The same we'll summarize again. In nominal, there are only categories while there is no order, there is no equal interval, and there is no true zero. Example is a blood group. Ordinal, in ordinal, you have got categories as well as order, but there are no true equal intervals and there is no true zero. Example is a pain severity. While in interval score, because this is a continuous type of data here. Okay. Uh, this was a categorical type of data. Okay, or qualitative data, you can say. Here, it is a quantitative type of data. So categories are not there, but there is a order. There are equal intervals, but true zero is not there. Celsius temperature is the example. Another example, what we have seen is the IQ. Okay, that was also example of interval scale. Then in ratio, you have got order. There is equal interval and it has got a true zero. Example is a weight. Okay. Now, important concept is a qualitative versus quantitative variables. We have discussed the variable may be qualitative or it may be quantitative. Okay, so qualitative variable or the categorical variable includes nominal and ordinal. That is why I said this, you study these together, nominal and ordinal. This is applicable for qualitative or categorical type of variable. So this is the scale, nominal scale, ordinal scale. Okay, so qualitative and categorical variables, you have nominal and ordinal scale. Then quantitative or the numerical variable is there, then you can have either interval or the ratio scale. Okay, interval example also you have seen, and ratio scale example also we have seen. We have also seen the categories. Okay, characteristics of interval and the ratio scale. Okay, now coming to the conversion of variable. Okay, sometimes the quantitative variable can be converted into qualitative variable. For example, HDL cholesterol less than 40 milligram, you may categorize as a low HDL, and more than or equal to 40 milligram, you may categorize it as a normal HDL. Okay, so low HDL becomes one category, this becomes another category. So your quantitative variable now has become a qualitative variable. Another, there is a blood pressure. Okay, more than 90 millimeters of mercury, you may classify this as a categorical variable as a hypertensive. Less than or 90 millimeters of diastolic blood pressure, you may label this as a normotensive. Okay, so converting continuous data into the categories may simplify the analysis and reduce the information. Okay, so sometimes when you have a large type of data, but if you categorize the data into this particular way, it will simplify the analysis and reduce the information. Okay, next is a statistical method which is based on the data type. Okay, now what are the different statistical methods will also depend upon what type of data you're dealing with. Suppose you have a nominal data, then you will measure the frequency and the percentage, and you will use the chi-square test. When you have a ordinal data, you will measure the median, and the test which is applied is a Mann-Whitney U test. Okay, it is a Mann-Whitney U test. Then if you have got a higher level of data, that is interval or ratio scale you have, then you will summarize with the help of mean and standard deviation, and you will use the t-test for the comparison. Okay, so data type and determines the statistical test. Now the blood pressure, which is a continuous variable. So continuous blood pressure variable is a continuous variable. So appropriately, how you are going to describe with the help of mean and standard deviation. While hypertension is a category, yes or no, you will describe with frequency and percentages. I hope you have understood. So you have converted the continuous variable into the categorical. So when you are dealing with continuous variable, you will use mean and standard deviation. But once you have made it as a category, you will have the frequency and the percentage. Okay. So from examination point of view, blood group is a nominal, eye color is a nominal, then socioeconomic status is ordinal, pain severity is ordinal, Celsius temperature is an interval, weight is a ratio scale, height is measured in the ratio scale, pulse rate is measured in the ratio scale, cancer staging is ordinal, and age is also a ratio scale measured. Okay. Then commonly, what you should remember, temperature in the Celsius is a interval scale. Temperature in Kelvin is a ratio. Okay. So temperature which is measured in a Celsius becomes the interval scale, while temperature in Kelvin is a ratio scale. Okay. Apgar score is ordinal. Then Likert scale is ordinal. The number of children is a ratio or the discrete quantitative. It is a discrete quantitative number of this children. Okay. Then gender is a nominal scale. Okay. So internal scale, there is a zero is arbitrary and difference is meaningful, but the ratios are not meaningful. So in interval scale, zero is arbitrary. There is no true zero. It is an arbitrary zero. Differences are meaningful, but the ratios are not meaningful. Okay. Then ratio scale, there is a true zero. Both differences as well as ratios are meaningful. Okay. So these are the important concepts in the today's session. So we have few questions, doctor. Can you please go through the questions?
Yes, sir. Question number 1. A researcher record a blood group of antenatal woman. Which level of measurement is used? A. Ordinal, B. Interval, C. Nominal, and D. Ratio. So it is C. Nominal.
Correct, correct. So it is a nominal categorical data is there. So blood groups are categories without order. Next.
Question number 2. A pain severity recorded as a mild, moderate, severe. It is A ratio nominal, C interval, D ordinal. Sir, it's D ordinal.
Yes, it is the ordinal. Okay. So there is a order, intrinsic order is there. Okay. Categories have order but unequal intervals. Okay. Next.
Which variable is measured on the interval scale? A weight, B temperature in Celsius, C pulse rate, and D height. Interval is temperature in Celsius.
Yes, temperature. And there is no true zero over here. Okay. So temperature in Celsius. Next.
Which statement about the ratio scale is true? No true zero exists. Ratios are meaningless. True zero is present. Only categories are present. Ratio. Sir, true zero is present.
Yes, that is the highest. Everything is present. Okay. So true zero is present here. Ratio. Okay. Next.
A patient weighs 80 kg and another weighs 40 kg. Which statement is correct? A weight is ordinal, weight is interval, ratios are meaningful, zero weight has no meaning. Sir, it is weight is zero weight has no meaning.
Here, does the ratio have meaning or no? What type of data it is? It is a continuous type of weight is a
Continuous.
continuous type of data. Okay. And
Yes.
what type of scale it is there? Ratio scale. Ratio
Ratio scale.
scale, everything is meaningful. In ratio, everything is there. So ratios are meaningful because 40 kg is going to be two times of the 20 kg.
Times of the 80 kg.
And okay,
Yes, sir.
like that. Okay, so the
Yes.
ratios are meaningful over here. Okay, which is not
Yes.
happening with the interval scale. Okay.
Yes, sir. Question number 6. Which variable is qualitative? A weight, B blood pressure, C gender, and D pulse rate. Qualitative. Sir, blood pressure?
No, blood pressure again a continuous type of variable. Quality
Sir,
here.
gender, sir.
Gender, correct. Okay. Next.
Question number 7. Which statistical measure is most suitable for ordinal data? A mean, B standard deviation, C median, D variance. Suitable for ordinal data. So median.
Correct. Here it is a median we are going to use. Okay. So quick revision. Nominal has got only categories. Ordinal has got ordered categories. Interval scale, the equal intervals, but there is no true zero. Ratios will also have equal interval, but there is a true zero. So ratios become meaningful. Okay. So for remembering purpose, NOIR, N is a nominal, O is ordinal, I is interval, R is a ratio. So hierarchy is there from nominal, then ordinal, then interval, and the ratio is the highest type of scale. Okay. So from examination, blood group is a nominal, pain score is ordinal, Celsius is interval, temperature is interval, then weight is a ratio scale. Ratio scale has got true zero. Ordinal data have ranking but unequal intervals. Statistical test selection depends on the type of data. Okay. So that finishes our topic for today's discussion. That is the level of measure.